This visualization represents the millions of digital transactions executed invisibly every second. APIs function as the foundational connective tissue of modern business infrastructure. They route data for cloud infrastructure, synchronize complex microservices, and process third-party partner integrations. Yet, despite handling the bulk of modern commerce, these interfaces operate out of sight for end users and are rarely factored into executive risk models. Because it operates in the background, the API layer is frequently misunderstood by leadership, leaving the most critical engine of modern business underprotected. The professional blind spot starts with the assumption that securing a web application's user interface automatically secures the back-end APIs. IT departments allocate massive budgets to traditional perimeter defenses and application security to lock down interfaces. Modern attackers ignore those barriers. They bypass the application interface entirely. By circumventing the UI, adversaries interact directly with the APIs, gaining programmatic access to raw business logic and back-end databases. A traditional attack attempts to manipulate the visible elements on a screen, whereas an API attack targets the hidden logic executing the commands. Focusing on UI security while ignoring API testing is like building a bank with an impenetrable vault door, but failing to construct exterior walls. To understand this vulnerability, we have to look at how legacy security tools operate compared to actual API architecture. On the left, traditional web application testing uses automated crawlers to navigate down a directory structure, clicking links and filling out HTML forms. On the right side, APIs bypass web directories entirely. They rely on structured JSON data blocks flowing directly into backend server nodes. Legacy testing is designed to catch specific front-end vulnerabilities, like cross-site scripting or SQL injections. API vulnerabilities involve logic flaws, token abuse, and data manipulation. While web scanners map targets automatically by following links, APIs do not broadcast their structure. They require specific OpenAPI or Swagger documentation just to be discovered. Relying on traditional web application scanners for modern infrastructure means your primary attack surface remains hidden from your security team. The OWASP API Security Top 10 provides a framework for these specific threats, mapping critical business risks rather than just technical checklists. The most prevalent and damaging vulnerability on that list is Broken Object Level Authorization, or BOLA. This diagram shows the mechanics of BOLA, starting with a legitimate API request. A user asks the server for their data using an identifier, like ID 105. The server processes it, returns a green 200 OK status, and delivers the data packet. In a BOLA attack, the adversary alters the object identifier within that same request structure. The server again returns a 200 OK status, but this time it hands over the data for user 106. The architectural failure here is distinct. The API verified the user's identity, authentication, but it failed to verify if that user actually owned the requested record, which is authorization. Automated security scanners miss this. The request syntax is valid, meaning there are no malicious payloads to trigger a technical alarm. A minor oversight in logic results in a mass data breach, occurring beneath the detection thresholds of traditional security perimeters. This reliance on logic over structure also leads to a vulnerability known as excessive data exposure. This diagram shows the result of developers sending exhaustive data objects from the API to the client. The mobile application interface displays only a user's name and a profile picture, while the UI filters out the rest. An attacker intercepting the raw API traffic bypasses the UI filter. This reveals the raw JSON data structure underneath, exposing hidden fields like email addresses, physical locations, and payment history. These data streams are further complicated by the lifecycle of the endpoints themselves, a risk categorized as improper inventory management. Over time, organizations abandon deprecated API versions, leave test environments running, and spin up shadow APIs outside of official protocols. These forgotten interfaces remain active on the network without modern security controls, creating an unprotected backdoor directly to the database. Comprehensive API discovery is a prerequisite for data protection. You cannot secure infrastructure if you do not know it exists. Automated security scanners provide rapid, large-scale discovery of known signature-based vulnerabilities. Their limitation is that they cannot comprehend business context, workflow hierarchies, or application logic. An automated tool cannot determine if a user maliciously altered a shopping cart price to 0 or bypassed a multi-step financial approval workflow. This diagram shows an adversary linking multiple structurally valid API requests. By sequencing these calls, the attacker bypasses a standard security gate and successfully accesses a restricted data node. Because each individual step of the chain is syntactically correct, automated scanners read the attack as normal, authorized traffic. Automation alone is structurally incapable of defending against modern API attacks because it evaluates code syntax rather than business intent. Securing modern architectures requires a methodological shift toward contextual API penetration testing. This involves expert-led manual testing that evaluates the interaction and logic between multiple endpoints to proactively break those chained attacks before they occur. The stakes extend past technical remediation. An exploited API results in operational downtime, disrupted financial transactions, and the destruction of customer trust. It also triggers regulatory scrutiny, making contextual API testing a requirement for compliance mandates like ISO 27001 and SOC 2. API security must evolve from an isolated developer task into a strategic, boardroom-level business control. Digital resilience depends on the rigorous protection of the hidden logic powering the business itself.